Hey guys, and welcome to this lesson all about solving absolute value equations. So let's take a look at our first examples. And in our first equation, we're asked to find the solutions to the absolute value of a equals 5. Now for me, I think it's a lot easier to approach these problems by kind of speaking about them in a way that makes sense. Remember, we talked about the absolute value of a number being a measure of that number's distance from 0 on the number line. So basically what we're being asked here is please find a number or numbers whose distance from 0 on the number line is 5. So, if this is 0 on the number line, I'm thinking if you are 5 units away from 0, you're either going to be 1, 2, 3, 4, 5 units to the right, or you'll be 1, 2, 3, 4, 5 units to the left. So I think our solutions in this case are going to be the numbers 5 and negative 5. And if you think about it, if I were to substitute either of those numbers in for our variable a, we get a true statement. So in this case, we have two solutions to this statement. I could say that either a equals negative 5 or a equals 5. And this is just by intuition. That's it. Let's take a look at our next example. In this one, the absolute value of our unknown w equals 8. Well, this means please find a number or numbers whose distance from 0 on the number line is 8. And that means, okay, well, which numbers are 8 away from 0 on the number line? Those numbers are going to be positive 8, 1, 2, 3, 4, 5, 6, 7, 8. Right here, 8 units to the right, or negative 8. Right? Those are the two numbers who are 8 away from 0 on the number line. And that's it. So our solutions in this case are w equals negative 8 or w equals positive 8. Not so bad. And so I'm finding that when we have equations that are just the absolute value of some number equals 10 or 8 or 17 or what have you, it's not so bad. Again, we're looking for a number or numbers who are 10 units away from 0 on the number line. So I think those numbers are going to be positive 10, 10 units to the right of 0, or negative 10, 10 units to the left of 0 on the number line. All right, not so bad. Note to self, I just kind of want to put a note out here, that imagine we had instead the absolute value of, x is equal to 0. Note that if you are 0 units away from 0 on the number line, you must be 0 yourself. So in this case, you'd actually have only one solution. And I hope it makes sense that if you had the absolute value of y, for instance, was equal to something like negative 6, careful, the absolute value of a number can never be negative, right? The distance from 0 on a number line can never be negative. Negative distance doesn't make sense in this case. So this equation right here would have no solution. So I just want to make sure we don't kind of fall into too much of a sense of just going through the motions with these types of equations, but I hope that we're able to kind of approach these with some degree of intuition. Okay, now what if we get a little bit more adventurous? And now we're asked to solve the equation, the absolute value of x minus 6 is equal to 3. So we're going to kind of explore both an intuitive and more kind of notation-based way to handle this. So what does this mean? If it were just the absolute value of x equals 3, that would be, well, that means x is 3 units away from 0 on the number line. Right? We're thinking absolute value is kind of distance from 0 on the number line. So what we can say here is this, that two ways to think about it. Either x minus 6, that number, whatever it is, right? I don't know what x is. I don't know what x minus 6 is, but x minus 6 is a number, right? And that number is 3 units away from 0 on the number line, right? And we know which numbers are 3 units away from 0. Those numbers are 3 and negative 3. So if we kind of had a number line here, what I would say is that, well, if here's 0, my claim is that here's 3, x minus 6 could be 3, or x minus 6 could be negative 3. Right? We're thinking that this number right here, if its absolute value is 3, it's 3 units away from 0 on the number line. And now we have two simple equations that I think we can solve. For the one on the left, I think we end up with x happens to equal 3, coincidentally, or x equals 9. All right, so we found our two solutions, x equals 3 and x equals 9, but I want to use these to kind of highlight a different way to think about our original equation. So here's how I actually like to think about that original equation. Note that, remember, the answer to a subtraction problem is known as the difference. So this is kind of saying that the absolute value of the difference between x and 6 is 3, meaning that x is either kind of 3 bigger than 6 or 3 smaller than 6, that this difference is either positive 3 or negative 3. And that's what this means. This is really just saying that x is either 3 bigger than 6 or 3 smaller than 6, that the absolute value of the difference is either 3 or negative 3, its absolute value is 3. So this is just saying x is 3 away from 6. That's it. So you can almost think of 6 is your kind of new centering point, and x is either 3 units to the right on the number line or 3 units to the left, yielding us those same two solutions of 9 and 3. Very interesting, very interesting. And that second way we kind of went through it, I think is going to be far more powerful. So let's do another example. All right, in this example, very similar. We're going to kind of do it two ways. First, I'm saying, all right, the difference between x and 15, that's what the answer to a subtraction problem is. The difference between x and 15 could either be 9 or negative 9. That means that x is either 9 greater than 15 or 9 less than 15. So if 15 is kind of our center number, we can either go 9 to the right on the number line or 9 to the left on the number line, yielding our two solutions of 24 and 6. And heck, if you actually substitute these in, you will get some true statements, right? 24 minus 15 is 9. The absolute value of 9 is 9. 6 minus 15 is negative 9. The absolute value of negative 9 is 9. So here's just kind of an intuitive, visual way to solve this equation, I think pretty easily. So we already know our solutions are going to be 24 and 6. Okay, if you want, you can also go with the whole, whatever number this is, x minus 15, that number, its distance from 0 on the number line has to be 9. So x minus 15 could either equal 9, or x minus 15 could equal negative 9. Right? This is a different way of thinking about it, but it will yield the exact same results. As you see, our two solutions, 6 and 24. Once again, I really enjoy this method, but if you need to, you can also rely on this. All right, two more examples. What happens when I have something like x plus 7 equals 2? Well, just notice that x plus 7 can be rewritten as x minus negative 7. The absolute value of that is equal to 2. Okay, so we say, oh, the difference between x and negative 7 is either 2 or negative 2, right? So this is just saying that x is actually 2 away from negative 7. All right, negative 7 is kind of our center number, if you will. And we're saying that x is 2 away in either direction. So x can either be negative 5 or negative 9. Boom. Those are our two solutions. Similarly, you can think about it as saying, well, x plus 7, whatever number this is, its absolute value is 2. So x plus 7, that number has to either equal 2 or that number x plus 7 has to equal negative 2. In which case, once again, we get the same solutions, x equals negative 9 or x equals negative 5. So we're using both intuition and some kind of more formal algebra to solve this equation. Last one, maybe you want to pause the video and give this one a try on your own. Try to solve the absolute value of x plus 22 equals 10. Why don't you try it? Pause the video and give it a try. All right, well in this case, same idea. I think of this as x minus negative 22 equals 10. So we're saying, okay, the difference between x and negative 22 is either 10 or negative 10, right? Because the absolute value of that difference is 10. So we're saying, hey, either x is 10 greater than, negative 22, or x is 10 less than negative 22. So here's negative 22. X is either going to be 10 greater, so negative 12, or it's going to be 10 less at negative 32. So here are the two solutions to that equation. And note to self, you can actually substitute these in, and you'll see that it works. Negative 32 plus 22 is equal to negative 10, whose absolute value is 10. Negative 12 plus 22 is equal to 10, whose absolute value is, well, 10. So two ways to go about solving these absolute value equations. I will say that this method right here is going to be far, I think ultimately it's going to be better because I think it's more intuitive and easier to understand, and it's really going to help us when we do absolute value inequalities later. So that's it for this lesson. I hope you found it helpful, and I hope you enjoyed.